So the left-hand side of the equation we can rewrite as a plus b over ab is equal to 3 over 2018.
Yes.
So therefore we can say 2018 a plus b is equal to 3 ab.
Yes. Then what?
Okay, and then for this I used the above Simon's favorite factory trick.
Yes.
Okay, so then from here basically I said, so 2018 plus a times 2018 plus b, that's
2018 A plus 2018 B is equal to 3A.
yes sir. And then from there I said, so then I expanded this to 2018 plus a in brackets 2018 plus b.
So when we have these, we should do something. I think I explained for you here. Pay attention to this problem. You should use the
Yes sir.
same approach to be able to factorize. Pay
Okay, so
attention to GSFFT. This one we can say SFFT. This one general form. If you pay attention here, we should do something. What should we do?
I remember in my original, the original time I solved this one, I got further than now. But hold on, let me try with the GS SFT.
Okay.
Let me try. So over here you multiply by 2. You multiply that by 2, but
No, in that case, it was, look, in that case, it was 2, so we multiply by 2, then 2A, 2B, okay? Because it was 2, we multiply by 2. Now here we should multiply by what?
by 2018.
No. Compare these two, look, here. For this one, we multiply by 2. So for this one, we should multiply by what?
My mistake. By 3. We should multiply by.
Exactly, by 3. Okay, so you can multiply by 3, and like this, you can multiply, you can factorize, okay? Wanna try the rest on your own?
Okay, I'll try.
Okay.
Okay, sir. So basically, now we can say that 6054 plus a, and then the second one is 6054 plus b is equal to
9AB minus 6054A minus 6054B is equal to 0. So, if you factorize this part, what times what is equal to what?
okay, 3a minus 2018, 3b minus 2018, and then you would have to do minus 2018 squared is equal to 0.
3A minus 2018, 3B minus 2018 is equal to
2018 squared.
2018 squared, exactly. And it says find
Okay,
all
so,
ordered.
so actually, sir, what I got in the beginning, right? The first time I tried this, what I did was, okay, so I reached the point where we have 2018 a plus b is equal to 3ab, right, sir? So then what I tried from there was I did 2018 plus a, 2018 plus b is equal to is equal to okay, so in the beginning I didn't multiply by 3 the first time I tried it.
Yes. If you multiply by 3, then it will be so much easier, right? Now you should
Yes, sir.
find all positive integer cases for A and B.
Yes, sir.
Do you want a hint or want to try the rest on your own?
Okay.
Okay, sure.
So, sir, I will start by factorizing 2018 squared and seeing all the combinations of multiples which multiply to 2018 squared. Is that correct?
Yes, but we can reject a lot of cases here because this number is what mod what 3a minus 2018 is congruent to what number mod what number?
1 mod 3.
Exactly.
But
It's 1 mod 3. So when you want to consider cases, we should pay attention that it is 1 mod 3, right?
yes, sir.
Now, 2018, if you prime factorize, is equal to what? It is 2 times 1009, right?
Yes, sir.
Okay. Did you prime factorize 1009?
It seems to be prime number, sir.
Okay, you should check divisibility until what number?
I'm not sure what's the standard number that you should check until, sir. I just check until like 7.
No. Look, when you want to make sure a number is prime or not, look, that year, this is for Putnam 2018. So before the exam, you should know the prime factorization of the year. For example, for this year 2024, 20 next year 2025. Okay, so students know this. But if you want, in general, if you want to check a number is prime or not, for example, like 1009, you should consider square root of this. Square root of 1009 is around 31 point something. Okay, 31 or 32? 32 squared? No. 32 is 1024. It's 31. So you should check divisibility of these by prime numbers all the way to less than or equal to this number. Okay, so we should check
Okay.
by 2, by 3, by 5, by 7, by 11, by 13, 17, 19, 23, 29, and 31. Okay?
Okay. I see.
Okay. If you check, for example, this is not multiple of 2. It's not multiple of 3. It's not multiple of 5, 7. 30, 29. It's not multiple. So for 11, do you know the rule for 11 plus minus like this?
No, sir. What's the rule?
Yeah, so let me tell you
I know for 3 digits. I don't know for 4 digits.
it's not important number of digits is equal to what? For example, let's suppose that we want to find. Do you know the rule for mod 9?
Yes, sir. So some of the digits has to be divisible
Yes.
by 9.
And do you know what's the reason?
Do I know what's the reason? Because I know that for mod 3 the sum has to be 3. So then for 9, if you divide by 9 is 3 squared. So if you do it twice.
Uh, well, we
But
want to solve it
sorry,
with mod.
I'm not sure
Okay.
how to derive that.
Okay. So let me tell you the reason is what here. For example, suppose we have 5, 4, 9, 8, 2. Okay. So it is equal to what? 2 plus 8 times 10 plus 9 times 10 squared, right?
Yes, sir.
Plus 4 times 10 cubed plus 5 times 10 to the fourth, right? Now I want to
Yes, sir.
calculate this mod 9. Before that, can you tell me 10 mod 9
1.
is equal to, yes, is equal to 1. So instead of each 10, you can write 1. So it would be 2 plus 8 plus 9 plus 4 plus 5. Sum of the digits, right?
Yes, sir.
Okay, so it is the reason, this is why we add the digits for finding mod 9. Now let's consider mod 11. Again, if I use the same number here, can you tell me, let me copy. Can you tell me 10 mod 11 is equal to
10.
number?
10, sir.
10? No.
Or,
Yes, but
or
we
minus
want
1.
minus 1. So it is equal to 2 minus 8 plus 9 minus 4 plus 5, right?
Yes, sir.
So from right, you should say plus, minus, plus, minus, plus, and so on, right?
Yes, sir.
So then we want to check mod 11. We say, okay, 9 minus plus this, it's 9 minus 1, 8, so it's not multiple of 11, okay? And if you check all no other numbers, you will see, okay, it's not multiple, so 1009 is prime, right?
Yes, sir.
So it is 2 times 1009 times 2 squared times 1009 squared, right?
Yes, sir.
So when you want to consider cases here, for example, it is not possible to have 2 here because we proved each
Yes,
of
sir.
them should be 1 mod 3. So you can ignore some of the cases, right?
Yes, sir.
Okay, so try to find all possible answers such that
Okay.
A and B are positive integers.
Okay. I can try for a little while from here, sir.
Sure.
Okay, sir. So 2 squared and 1009 squared, they're each equal to 1 mod 3. So basically,
Yeah.
then we can say that one term is 2 squared, one term is 1009 squared, right?
Yes. One case is this. We have more cases. You can also say 2 times 1009, 2 times 1009, right? Okay, so we should find all of the cases. Do you want a hint or want to keep trying?
I'll keep trying, but then I'll let you know if I need one. I might need one, but I'll keep trying first.
Okay, sure.
Okay, sir. I think I have the answer. I think I got the answer.
Okay, so
Oh,
what are the
So,
answers?
okay. So 3a minus 2018, 3b minus 2018, these are basically identical. So they'll be in two sets. So basically, it'll be A, B, and BA. So let's just focus on one side first, right? So
Yes.
the combinations that I found. So 1009 squared, 2 squared. The 2 times 1009, 2 times 1009 doesn't work because it
Ah, yes,
doesn't
yes.
become.
Yes, it is good. Can we can also write all divisors of this to check. Okay, so you said 2 squared this. Tell me all of the cases for this part.
Okay. Okay. So sorry. Okay. And then the second case, you wrote 2 times 1009, 2 times 1009. That does not work because it's not a positive integer.
A and B are 0. We know that this one. No, why it doesn't work? No, in this case, look, 3a minus 2018 is this. That 3a is 2018 plus this, not minus. Understand?
Yes. Sir. Okay.
In this case, can you tell me? Let's write A and B for these cases. For the second case, A and B are what?
The second case. Okay. Let me work it out. Let me work it out again and make sure I got it right.
Okay, sure.
Yes, sir. So it doesn't come out to an integer. So A and B will be in this case 4036 over 3.
Let me check. 2000, 2 times 1009. Because 1009 is because it is 2 mod 3. We shouldn't check this, right?
Yes, sir. So that's why I
Yes, yes,
found
yes.
that
Good job, good
it
job,
wasn't
good
an
job.
integer, so I
Yes,
canceled it
good job.
out.
So the first case is this. What about second case?
Uh, okay, so then afterwards you have I found 2 times 1009 squared and 2, but that also doesn't work out to an integer because it's 2 mod 3. So
Exactly.
that doesn't work either. But the
Yes,
last one, 2 squared times 1009 and then 1009, that does work. That gives us 2018 and 1009.
yes,
Or and then 1009 2018. So there, you reverse them as well. So then
yes.
we have total 4 answers. The first
But
one
let me
is.
ask you this. We can also have
Yes.
negative cases.
But sir, it said that A and B must be positive
Yes, A and B
integers.
are positive. So when A is positive, it is at least what?
Oh, okay.
Okay.
I see. A and B are positive, but the terms themselves can be negative. Okay, I see.
Exactly. So also check those cases.
Okay, I see. But sir, for the negatives, I still don't. I'm not finding any answer for the negatives.
Okay, so let's check. One of the answers, look here, negative of these numbers don't work because they are 1 mod 3, negative 1 is 2, right? So
sir.
it should consider -2. So it means that, for example, we know 2 doesn't work, but -2 and -2 times 1009 squared is good. Agreed?
Yes, sir.
Okay, so the answers with that here, with positive, don't work here. They work because we consider -2 is good. So it is one of the answers. What else?
And then okay, then we can have. Hold on one second, sir. Yeah, we can have minus 2 squared and then minus 1009 squared.
Yes, but let me tell you something. Here, this number is a large negative number, right? We said, can
Yes,
you
sir.
tell me what's the minimum of this?
Has to be greater than or equal to minus 2018.
2015. Because A is at least 1, right?
Okay, A is at least one. Yes.
Yes, but this case is bad because this number is less than this, right?
Yes, sir.
Okay, so what else can we do here?
Then
Negative
then
what?
we can have.
So let me tell you something. Because look, if you write all these things, maybe we miss some of the cases, right?
But
So
sir, the
one,
thing is, right? The thing that it has to be greater than or equal to minus 2015. I can't find a single case here where where both are greater than or equal to 2015 because they both have to be so, right?
yes. You can say negative 2018, negative 2018 also doesn't work, right?
Yes, sir.
Yes. So here we can say because if they are equal, you can consider this negative 2018, negative 2018 doesn't work. So we can check all of them. But let me tell you an easy way to check all divisors, okay? Can you tell me this number has how many positive divisors?
Has four, sir.
No. Do you know the formula for number of positive
Oh,
divisors?
yes, you taught it to me, right? It's the it's hold on. Let me go back to the formula.
Okay.
It's Euler's torsion function, right?
No, 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 no. It is number of positive divisors. Let me ask you this. For example, if someone says how many positive divisors does 24 have? Try this one.
Hello, sorry, 7, sir.
17. So can you tell me all
7.
how many? 7? So let's
7,
write
yeah.
them. 1,
124.
yes, 124, like rainbow idea goes like. Then what?
212.
Yes, what else?
3, and then sorry, 3 8,
What else?
and then 4 and 6. Sorry, so that makes 8, not 7. So 8. Yeah.
So how many positive divisors are there?
So there's 8.
8, right? Agreed.
Yes, sir.
Okay, so let me tell you the formula. When you prime factorize 24, it's what? If you prime factorize it, what's the prime
So it's
factorization?
okay. So 2 to the power of 3 times 3 to the power of 1.
Exactly. So, for example, look, 6 is a divisor. 6 is what? It's 2 to the 1 times 3 to the 1, right?
Yes,
8.
sir.
8 is 2 cubed times 3 to the 0.
Yes, sir.
12 is what? It's 2 squared times 3 to the first, right? So
Yes, sir.
when you want to calculate number of divisors, power of 2 can be 2 to the 0, 2 to the first, 2 second, 2 squared, 2 cubed, right?
Yes, sir.
3 to the 0, 3 to the 1. So all this one, 2 to the 0 times 3 to the 0 is 1, right? This one
Yes, sir.
is 3, all of them. So it would be what? It would be 4 times 2, which is equal to 8, right?
Yes, I agree.
Have you seen this formula before?
No, sir. I've not.
Okay, that's the reason we should check. So now we want to apply this
Okay,
formula for this number.
I
This
see.
number has how many positive divisors?
Okay, I see, sir. I see. So then this would have then 9.
Yes, so let's write all of them. 1 and then 2 squared times 1009. Next one is what?
Okay. Okay. Then 2.
2 and
2 and then 1009 squared.
2 times 1009 squared. What else? Next one.
Then 1009.
After 2, what's the next
No,
divisor?
sorry. 2 squared. 2 squared.
2 squared, yes, which is 4.
2 squared to 1009 squared.
Yeah, so 6 divisors so far, 3 divisors are left. What's the
Yeah.
next?
1009.
Yes,
And then
2
2 squared
squared.
times 1009.
Exactly. 1 divisor is left.
Yeah. 2 times 1009.
Yes, because this times itself is this one. So here is
Yes.
all divisors, okay? Now, if we consider these numbers, let's consider these numbers mod 3, okay? So if we
Okay.
consider mod 3, they would be what? 1, 2, next one is 1, this one, 1009. What is this
1.
one? Mod 3,
I think
1.
it's 1.
Next one, 2,
Then
right?
2.
1,
Yeah.
1, 2, 1, okay? So when we say this times this, it is good. It is one case. This times this is bad. This times this is good, right? 2 squared
Yes.
times. Also, this one is good, right? Agreed?
Yes, sir.
Okay, so when we write this, then we don't miss any of the cases. So the next one is 1009 and 2 squared times 1009. So we have 3 cases in total for positive numbers, right?
Yes, sir.
For negative numbers, let me write this one with this. Okay, for negative numbers, the cases, what are the cases? We should consider negative
Okay.
of this
Okay. I
sign,
see. I see.
negative of
Yes. And
this.
then 2 times squared. I
Yes,
see.
this one also is bad because it's negative 2018. We know the minimum is negative 2050, right?
Yes. Yes. I see.
So we have these 3 cases to check, right?
Yeah.
Okay. So try to find out all of the possible cases, okay?
Yes. Okay. Okay, sir. Yeah, I'm done. So the
Okay.
numbers we get are 340,033. That's one. And then its pair is
340,000 and what?
and 33.
30. So
No, no, so, no,
this
no, no.
one, right?
So yes, yes, correct. And then 674.
674.
Yes, sir.
What else?
And then of course you swap the two as well. You can swap them for A and B.
Yes, exactly. We can
Um,
swap them. What's the next one?
okay. Then the next one 1358114.
1358114,
Eight.
right?
Yes, sir. And
Next.
then 673.
Okay, what's the last one?
And then 1009 2018.
100928. And you can swap them.
Yes.
So
I
six,
haven't
seven.
verified though. I haven't verified. Should I calculate and verify?
Okay, sure. And this one, 8114 and 2018 1001. Okay, let me check. Okay, the first one is 67313581114. Yes, this is one of your answers. Next one is 674 340,033. Yes, and last one 1009 2018. It says we have 6 answers. Yes, good. Completely correct.